this as nobody's there. All right, thank you guys for showing up. This is a presentation called Principles to Code By. It's a hand down from me from my mentor a long time ago that principles that I live and breathe when I make LabVIEW code. And when I look at other people's code, I look for these very specific things to kind of identify and isolate because they are telltale signs of thoughtfulness and intentionality in creating good code. So for those of you who did know the SMoRES acronym, this is kind of a redo of that and a little bit more information. So the basic idea is that we have a problem. Too many people, too many times, we end up with developers, even ourselves sometimes, where it turns out to be, we get the run arrow, it works the first time, what do? We do FI, ship it, pretty much. You can fill in the rest of the acronym there. But the basic problem is that that does not mean that it's done. That's usually when the hard work really starts, because it stops being creativity flowing and it starts to be actually more about how do we actually make this a good program as opposed to one that's just running. The next problem that I see is that the bar for quality has been definitely not moving up. It's been stagnant, or there are times where I've seen it move down. And this has been shown when I look at some people's code, and they groan when I ask them, and I say, this isn't good enough. This is not good code. And it's unfortunately can earn you a bad reputation for being a stickler, but I just see it as the quality bar is not high enough. And coding without vision is wiring in the dark. You know, I talked to Brian Powell, I showed him this, asked him, is that a good graphic for this? And he was like, that's actually cleaner than some of the diagrams that I've looked at. And I'll pull up some ones that I've seen before, but the problem is that when we start just coding, we don't think about, one, having guiding principles that we know are going to take us to having quality code. We end up just creating stuff and dropping nodes and dropping functions or creating entire architectures or systems that are just ends up being rat's nest because we were only trying to get that very first tar up top to make it running as opposed to saying, how should this be done? So, I will go ahead and this is good for this presentation. So I'll ask you to grab your cell phones out real quick. If you don't mind getting a little bit of mustard on them. And go ahead to full screen off. I need to start this. This is a basic poll. We can do it by hands, but the basic idea is what level of developer are you? And so this is a question to really get out to the audience because this presentation can take a couple different tacks in terms of the examples and the ideas. But the basic one is, your basic three ExpressVI. You start to use some kind of structure like QMH from the sample projects. You've used that, and then all of a sudden you create some massive rat's nest of code, or you actually start off with an actual intentional design of functional components. So we don't need to go into this right now, but because everybody here is an architect level. But I believe that we're either in between these two or at that point. But I will talk about examples that maybe go down a little bit lower than things that we might already know. So, let me ask what to move forward. So, this is a phrase that came to me a little while ago, and I realize it's more of a marketing buzzword now, but it's this idea of stop reverse engineering and start forward engineering. Or if you're not, try to stress the importance of this idea to the people that you work with. Every time that you step into a piece of code and you have to devolve what that piece of code is actually doing, you are reverse engineering. You are wasting time not solving the problem, but figuring out how to get to the problem itself. So, a couple truths associated with this. Code rarely dies, and sometimes often turns into zombies. We just can't kill it. The code that we create or the people that we work with create, we just can't stop using their code or spend time refactoring all their code to make it clean and in our system. There's too much risk that ends up being associated with it. So we just let all this piece of zombie go around our code and continue to live. So it's necessary to start from the beginning, as I mentioned before, with the intent of creating quality. The other one is that project scope is rarely, come on. The idea is that project scope is rarely static. I have yet to present and talk about scope creep in projects and not have at least half the room or all the room break up laughing about, oh yeah, projects never end up having the same scope. There's always some creep that's associated with it, either because you weren't, things you couldn't have prepared for, or things that you just didn't prepare for at the onset. And the other thing is that we want to be making progress. Progress in a variety of ways. Progress to make more money for ourselves so that we can spend time doing more of those things that actually matter. And if we're always in the weeds, always in the dirt, always trying to just get stuff going, we never have any time to be creative and to kind of build up our own internal assets of just creativity. And the idea behind this is we need to stress every time that we don't think about what we're coding, we just start coding, we are causing everybody to go in circles. You know, this idea of reverse and forward and reverse and forward. It's not just a straight line back and forth, but sometimes it's a downward spiral on the bottom of the toilet. But we need to have this in mind as we start to talk to people that we work with, or even ourselves as we code in our own little room. And so this is some thing that I've mentioned a lot, and I love the paradigm. Who's been in a skyscraper before on a windy day? A couple people. Have you ever looked in a toilet in a skyscraper on a windy day? You'll see the water in the toilet slowly move back and forth. And I want to talk about Type A 101 here. The interwebs are nice to me. This should work pretty quick. This is a mass damper system, huge, 750-ton block in the bottom of that tall building. And this is during the earthquake, I think like in 2012 or 2008. Now normally it moves just a little bit, but this is how that building didn't fall. It flexed. The design of the building wasn't, I'm going to be the tallest building, it never moved. It was, I'm going to have to move, I need to flex, and this very elegant system, not only visually appealing, but also architecturally significant, is moving, feet. 750 tons moving feet, balancing this building out to deal with the shape of the unexpected. They expected the unexpected, they designed it into it. We need to build that same kind of flexibility into the things that we create. So you can see the size of it relative to a person there. Okay, so this is one of my favorite acronyms, SMoRES. Stands for scalable, modular, reusable, extensible, and simple. Now the order of it is significant, we're going to talk about that. And just the idea of remembering it is important. Unfortunately, I've yet to find a way to get people to have this tattooed on the inside of their eyelids like I have. Because people go like, oh yeah, it was like reflexible and maintainable and excruciatingly painful to program. Rarely do people remember this, so I wish I could have something to hand out to you to actually remember this, but if you can at least remember that picture, it'll get you moving down the right lane, and then we're going to go through these individual things. But the idea is that with every VI, or also every system, for us as architects too, how can I make this? How can I make what I'm doing right now scalable, extensible, and so on and so forth? A quick shout out to my original mentor, Tim Jones. He works at L3 Communications at this point, but he was the father of SMoRES. The acronym was actually a little bit different then, and we'll get into that. But very smart guy, and he's taken this principle. He no longer programs Library. He is he's like a project lead, but he takes these very same principles away from working on wires and actually managing entire teams. And so this there's relevance beyond just our individual instance of LabVIEW that these concepts can go to. So the first one, scalable. How can I make this VI scalable? How can I make exactly what I'm doing, not really do anything else? How can I add one more to the system? Or more importantly, how can I add 50 more to the system, right? If you have a front panel that has 4 different clusters on it for your 4 different DAC channels, that's fine. But what do you make the user do when you have to add 20 more channels? Do all of a sudden they're responsible for scrolling your front panel down? That's just not workable. What happens on, yes? What happens on the block diagram? Do you have 2 new wires? Do you have no new wires? Or do you have 50 wires all going like that across your screen because that's the way that you started out the program? So as a quick example for this, got 2 that I'll go through very quickly. And feel free to chime in at any time. We all have a variety of horror stories. And what I'm thinking about in terms of getting feedback for this is good examples to code up within the next probably 24 hours to also stress these concepts. So if you see something that you don't see in my examples, you're like, you might really want to stress on that, feel free to mention it up. So the first example is the enumeration. So a user decided, hey, I've got this program in a device that's under test and it's got a set of commands. And so I need to make a front panel that lets the user select a command that just needs to be executed. Well, that's fine when it's 20 different commands, but it gets a little bit lengthy and hard to work with on the front panel. What about the block diagram? This isn't just the user experience, this is the programmer experience too. How do you get to what you need to get to here easily? It's a failure in scalability because somebody didn't ask, what happens when I likely need 50 more commands? Well, how about a scenario like this? Or so if that looks familiar to anybody? That type of behavior? What's the problem? Pick drop, that's right. I stole the guts of it. One of the benefits of working at NI, you get source code to things that you want to do. And I stole the guts out of it, and I turned it into actually, we'll talk about it in a little bit, but the logistics is, it's an individual sub-VI that you can drop out of your program. So the code will be available and accessible. You guys can use this and have this functionality yourself. But the idea was, imagine if quick drop was an enumeration. Who would use it? Right? But because the end product was thought of in terms of adding that many more. Let me see. So considerations. So that was the simple example. There's a more, so I have 3 levels of examples. That was the simple one, right? And almost any programmer is probably going to have to run into that. The more intermediate one is you're trying to do something creative in code, and you end up with a structure like this, and you don't know what object was explicitly set into your system, but you know that it's going to be one of these. So is this scalable? Sure, if you're willing to add 50 other things on the outside. I mean, I'll go ahead and open up the source code real quick. I mean, sure, it looks neat when I go like that. But in terms of scalability, it just doesn't hit there. So one of the things I asked is, hey, I'd never want to program like that again, so I went through the process. What happens if I have to add 50 things? And then there's a design pattern that I put out on the web called the manycast design pattern. I'll go ahead and do this. That effectively can make all of that a stacked sequence structure. And so it'll just go through 0, 1, you can see 0, 1, 2, 3, 4. It'll just keep going until it finds one that doesn't get an error on. And when it doesn't get an error, it stops executing. And if it gets to the end of everything and there's still an error, well, at that point in time it goes to the default because you don't have a 0, 1, 2, 3, and it errors out. Once again, thought about the problem. I don't want to make crappy code. I have to have a vision, and I have to eat my own dog food in terms of being determined to follow that vision as well. So what are the things that we need to ask ourselves and tell people when you look at their code and you review their code? Did you think about how many new wires were going to be needed and how unreadable your code's about to turn when I ask you for 5 more? And you can ask them, put another one of those in the system, show me how long it takes you. Time to integrate and refactor, or also the user experience. There's one last one that's really worth showing. Is this. A number pad, right? This is a long time ago that I had to make this. Oh, sorry, those aren't wired. You know, the basic library program is going to say, hey, that's how I'm going to program up my program. Because this is easy. This is simple, and it's done. But then what ends up happening when you have to go and you have to make it something, because the manager asked you in their scope group, well, hey, that thing works great. I need a whole number pad. What's going to happen to that event structure? It's going to blow up in your face. So you need to think from the get-go, what's the ways that I can get around that? Well, let me show you something kind of neat here. Hey, I need to add a new button here that's like a pre-programmed list of things. So I'm going to do e to the negative 3. Oh wait, sorry, this is the wrong one. I didn't need to use the de-evolution, I want to use this. So I'm going to take that k, actually make that e to -3 from there. So 6. I didn't wire anything, right? I could add a billion new buttons on there aside from Levy crashing. That would actually have worked. So that's something to keep in mind. So the basic technique behind the scene, I use a little bit of dynamic events. We can talk about those techniques at another point in time, or you get the example code and you look at it. Lastly, or not lastly, I'm sorry, nextly, that's the word, functional containment. When we ask ourselves after, hey, how can we make whatever we're doing easier, one more of them, how can we contain it? How can we functionally contain? How can we put bounds on whatever we're doing? Or where do those bounds even exist? And this is because you'll end up with functional Play-Doh if you don't. This is what the Play-Doh Corporation would make you believe that your children will create with Play-Doh, right? How many, they're like, oh, you create that so your kids will be able to pull the white off, the yellow off, the red off, and make this guy right there. Sure, yeah, right. Because what always happens? It always ends up looking something a lot more akin to that at the end of the day. Sure, some parts maybe you can pluck off, but most of it's kind of just this mush together. Every time we don't put functional bounds on parts of code, where we enable and disable controls versus how we're controlling flow of the program versus where the algorithm's happening versus all these other, this is what we're doing. Sometimes our programs look like that, but sometimes it doesn't, and it's just because nobody thought, what am I actually doing here? If I had to make sub-VIs, like 5 sub-VIs out of this program, where would those boundaries actually be? So, as you've heard me say some of these things, you have to ask yourself and stress the idea of where's the logical boundary of what we're doing here. Ask people. If you were to put one frame flat sequence structure on this program, where, or all over the program, where would those exist? Imagine if you were just like to blow up individual sub-VIs, or collapse your program into larger sub-VIs without having to go through that effort. Also, the idea is, how would it fit into other code? If you know that something has functional bounds, you also have to ask yourself, well, how would I take this and use it in a different point in my program? Are the wires going to be going into the right spots? Or are things not going to be lined up appropriately? Staying consistent is part of that. And then also the ease of use of that other module. In the example of this, I'm going to recreate context help, but instead of a floating window, two of the gentlemen in the audience should recognize this. So, this is a VI that simulates a little bit of ADCs, and that processes data, and it shows it on the screen. Very simple, but you want to actually have context help always visible on the screen, instead of having to have this floater window. So as I hover over these things, it brings up the specific description and tip for them. So the simple Labby programmer probably would have done something very similar to this, where they create a structure that says, for the specific buttons, all over the place, go ahead and, there we go. When I mouse over, you can't even see mouse over in there. When I mouse over, I actually take the description of the boolean and I put it into that string. And when I don't want it, I just go ahead and put a default string in there and it gets shown. But the problem ends up being, what happens when you end up in a scenario just like we had before? You add more. Well, what if I made, well obviously, if I made more buttons, this is scalable, right? Aside from the fact that I've got, I would have an event case selector that wide, I really wouldn't need to add that much more code to my program. So it is scalable. But you'll see that all these two event handlers are in the guts of everything else that might be in the program. If I were to go, where's the auto on that one, you'll see there's other stuff in the guts of there for a variety of purposes. Shrunk it down for the sake of the presentation. Well, what about if in order to get that kind of functionality, here's the same program, Evolution 2. This isn't changing at the moment. We'll go ahead and stop it. What about if I add in a brat VI? There's a child VI that controls the parent. How did I do that? It doesn't really matter how it ended up happening. The idea was, I knew there was a piece of functionality in my program. I knew it had bounds on what it really needed to do. It kind of interacted with all buttons on the front panel, and then there was a string control associated with it. Knowing those two things, there's going to be buttons and there's going to be a string indicator on the front panel with a hidden tag inside of it, basically. I just needed to add a sub-VI into the system. I could add this effectively onto any other sub-VI and make that work. And actually, you know what? Hey, we're getting short on time. The basic idea is, I thought about the problem. I realized I didn't want this event in with all the other events that were running my program. So I functionally contained it into a brat VI, or once again a sub-VI, a child VI that controls the parent. Next one, reusability. This is always a difficult one to present on because I just show the code that already exists. I don't really show any new kind of functionality. However, the way that's very interesting, or the comments that are very interesting that I've gotten about this, is that there's an increased level of, I guess with every different, whether you're simple, intermediate, or advanced, there's a certain level of commitment to what you're about to go down to stick with these reusable components. So if you're a basic beginner user, reusability, use the stuff that's already out there. You need to communicate TCP between two different programs, there's a library out there. VI Package Manager, once again, is something that now ships, if not already installed with LabVIEW. It's installed with 2013. What's that? It actually gets installed with 2013?
Yeah, the entire package.
Yep. So this comes on your system. There are libraries upon libraries of things out there for the stuff that you might already need to do. Use it. If you're not an advanced or intermediate user ready to make your own reuse libraries, just take the stuffs out there, and if you want to, emulate that. And then there's the idea of, well, I'm not just a beginner, I want to start making my own things. Don't start off trying to make a mass architecture that you're going to make your organization use. Come up with a template. Look at the things that you often do, and focus on just making a better starting point than a blank block diagram. And then finally, once you get up to the level of architect, it's either this or reuse templates that are available out there. Top level baseline prime is one. Extensible session framework is another. There are, those are just the ones that I've created, so I got them on the top of my head, but there is a lot of other reusable templates, starting points for people out there. But the sample projects in LabVIEW are another great example of templates that have taken you away from a blank block diagram syndrome and moved you forward. In the advanced case, there are frameworks and architectures. Actor Framework is one that's built into LabVIEW at this point, or now, I should say. There's also things like JAMA from Jet Engineering, I think, or Jet Incorporated. Aloha is another architecture that exists out there. There are some pretty beefy and feature-rich architectures that exist out there that you can not only start from not a blank block diagram, but not even a blank system of software. Everyone has their benefits and drawbacks in terms of features, speed, capability, functionality, debuggability. But once again, if you're not ready to start designing your own, use something that's out there. But there's one caveat, probably multiple, but there's one that's worth noting. You have to be committed to understanding how you're supposed to use it. Because if you start abusing frameworks, you end up in a real bad scenario because whoever designed it isn't perfect. God is not here on earth coding LabVIEW with us, right? We have these frameworks, they've got their weak points, they've got their strong points, and if you use them as they're designed, you can really save yourself a lot of time. If you abuse how they're designed, you can really end up in a lurch, and you contact the person, hey, I'm doing this thing with dynamic events that you had hidden underneath the hood, but I got a hold of and I started firing them off in my own system. And I now downloaded your new system and it's broken, fix it for me. And you know what their answer is going to be? You abused the design. Don't do that. I can't help you at this point. Maybe I can, but there's no guarantee. So in terms of, yeah, so I mean this is a very, this is far from all the available toolkits that are already available out there for different things. So you have to ask yourself, as you're programming or as you're developing something, you say, is this one of a kind? Am I never going to do this again? Is this one of a few? Yeah, I could probably use this a couple different places. Or is this one of many? Because every different step that you say yes to, you have to take somebody else's needs into consideration on top of your own, or even in front of your own. Like, your default values are not everybody's default values. And although it will require you to put a constant on your block diagram wherever it is, Now it's not only reusable for your own application, it's reusable beyond your own boundaries. Think about the next guy online. Actually, the statement I think some people put online, actually, Ed, I think you got it on yours. Think about the next person that's going to look at your code is a crazy psychopath that knows where you live. You know?
Not me, but I like that.
You like that one? Okay. Big or small reuse is time saved. So even if you're making a small thing, step back for a second, think about how maybe you or the next person might use this. And even if you have to go back to it and reuse only an idea of it, you will have saved time. And then I've already talked about speaking beyond your immediate use. Now, one thing that was stressed by Brian Powell was don't just take the code that you've written in your old program and call it reuse. And I added this at the end of it. It might just be refuse. Yes, reusing old code is fantastic. But if it turns into zombie code because it ate some stale food out of the fridge, the next thing you know, it's like a gremlin running around your code and you can't fix your bugs. It didn't, and unfortunately, the reuse you thought you were doing ended up wasting your time in the long run. So have, once again, intentionality. Stress this intentionality with the people that we talk to. Extensible. This is a fun one to actually talk about because the original acronym, if you remember up front, the E was actually small. Extensibility wasn't part of the acronym to start. But because there was room in the acronym with an E, I extended the acronym with extensibility.
Where's the N+1 on this?
SMoRES.
SMoRES?
Well, you only have an O to add on to now.
I do, but I optimized it out.
Oh.
That's only if there's time at the end. So, the idea ended up being you plan for future growth. You say, now how am I going to do another one? How am I going to put bounds on this? How am I going to make it reusable? How do I let somebody who's going to change my program in a way that I hadn't planned an easy path to the future? How did I make that easy for them? How did I make something like an example that happens inside of LabVIEW is when you, in classes for LabVIEW, when you create a new accessor for a property or a private data member, there's part of the C code that stops running the C code. Well, it's not C code, it's actually LabVIEW code inside of LabVIEW. Stops running the LabVIEW code that was developed by an internal person, goes out to disk, says, is there a VI there that can do something else? If so, pass it this information, and when it's done, come back to it. Another great one that I just thought of this morning was quick drop shortcuts. Right? How many quick drop shortcuts do you have on your system? Well, there's a default set that happened to be installed along with it. But the design of it was not hard code all the possible shortcuts at once and be done. The idea was that people are going to want to do quick drop shortcuts that I have no idea what are going to happen. But all I'm going to do is make a home for somebody's thing to fit. And if it fits within it, snaps onto the Lego blocks, now their thing is now part of the system. Or the thing that they use from their coworker or off the web is now part of their system. It adds on to their development environment. So the consideration for the couple different levels. For the beginner users, you're talking to somebody and you want them to think about having stuff added into their system, you can just simply stress, put a flat sequence structure in your code for me. Just let me know where I'm supposed to add something. Or, and an intermediate step also would be, you could even put a blank VI. Now, it could be abused, that blank VI, but if that blank VI gets a bunch of data that's relevant at that point in the program, and then it exits, your code really hasn't been hurt at all in terms of its performance. Not really. But now, for you to modify somebody's code, do you have to get into their block diagram to very specifically change what's happening? The answer is no. If they've designed it, hey, add an extra filter routine right here, or modify filter routine as a sub-VI. All you have to do is go in that VI, change whatever's happening there, and then you're done. You didn't have to drill down all these levels. Once again, you've extended what happens in the program. The ways to have this work well is to evaluate the hotspots of growth. So as you're asking yourself, like, how is somebody else going to want to do this? I created a framework called Extensible Session Framework that effectively just made named DVRs. you go. And so this is my answer for the ubiquitous latitude-style global timers. Because what happens when you need to do n+1? What happens when you need another timer? What do? Timer 2.vi, timer 3.vi. You know, that's, I won't get into the problems that I feel and get irate about with latitude-style globals. But the basic idea was I created a way to give a name and you get a reference to something out and you operate on that reference downstream. Very simple. Now I didn't need to do a bunch of stuff, but I figured, what about when, you know, this is kind of is the idea of making a single element queue. It's a little bit different, but I figured when people try to initialize their session the very first time, they're probably going to want to do something unique. Maybe connect to hardware, maybe make sure a file is on disk. Who knows? I didn't care. Actually, the one up front was what I needed immediately. So that was my need. But then I realized, I thought beyond myself, somebody's probably going to need to extend what happens when this reference closes the very last time. So I put that functionality at the end. So it's that idea of reusability, but underneath the hood here, I'm actually using classes and latitude that if I go into this VI that we see right here is framework. Somewhere way in the guts of this guy is this VI gets called dynamically. Now the user, this VI should be locked, and all the user has to do is put their guts of code here, and their code will be executed at runtime dynamically. They can extend the definition of this framework because I ended up using classes and I designed it as such. So it's not about how brilliant this design may and or may not be, but it's more about when we start to develop stuff, we've got to think about stuff's going to change, where's it likely going to change, how can I put something in there that makes the next guy's job for changing it more simple. And then lastly, balance creativity, or complexity, get creative and then get skeptical, is the way I like to put it. This is the order. Each one of these things built on top of itself to this point in a couple different ways. It built on top of, the acronym built on top of itself in terms of how easy is it to change certain things. First, it's doing the same thing again. Then it's putting bounds on it. Then it's making that thing that you put bounds on more reusable. And then it's how is it reusable, but how can I change the functionality? Each one of those things makes change easier to deal with. It makes your building more flexible. But how complex is it to actually walk up the building, to get up the building? Do you have to transfer through 12 different elevators to get to the top? So the idea is, once you figure out all these things, I have a problem, how can I solve it in these ways? Then you say, what is warranted at this point? Can my users only handle LabVIEW style globals, functional global variables? That's it. I don't have time to train them. I don't have time to support them. They've got to get something right now that only handles with what they've got. Fine. Use functional global variables. Don't let me work on the code afterwards because I'll only want to rewrite the whole thing. But it's only after you get to that point should you start to ask, how simple should it be? Because if you start off with simple first, you'll end up with a different S at the end of it. SH, ... fill in the blanks. And that's actually the problem. Because what happens when we figure out the simple problem? We got the car running, and we've stopped. That's all I need. I can use global variables all over the place. That's going to solve my problem. Fantastic. Then guess what happens? You've got an entire program made up of global variables. How are we doing on time? I don't want to. Anybody got to watch?
12:40.
Okay. When's the next session starting?
1 o'clock.
Okay. Is this all good? Anybody want to take a break and walk out? It's okay. No? All right. Thanks. I appreciate that. So the few things that we can ask ourselves in terms of simplicity, or actually one of the things I like to talk about is abominations of simplification gone awry, or when this last S wasn't addressed. Imagine, close your eyes for a second. I'll see at least a couple eyes and I'll keep going. Close your, okay, we got 2 eyes closed at least. Thank you. On 2 different people. You have a connector pane. It has 32 inputs. And they're all variants. You've just created the most scalable, flexible, extensible VI on the face of the planet. And then you open your eyes, and that's what somebody's giving you. That's the idea. I'm going to make my code all these things gone wrong. That's the simple. In the more intermediate one, things that can go awry. There's the idea of hey, these LabVIEW classes are neat things. I want to use these because I can get lots of benefit out of them. But I got to create 800 VIs for each one of my accessors. And all I need to do is maybe create a real simple widget. Well, that's really great because it's scalable, but did that extra functionality and features and complexity warrant saying, no, I could have just gotten away with the pairing database, string in, data out, do the cast. I'm not a fan of it. It kind of falls short on a couple different places, but if I really got to get something done, or once again, if the problem warrants it, I'll go to that. Once I've figured out that I can do all these other things. Also, the other one that is very interesting for us as architects, don't let our creativity think that we don't need to do good requirement gathering. It's this idea that if you only ask the person, really, it's like, hey, I need to create a temperature monitoring system. So I'm going to make something that can have 10,000 channels on it, no problem. Did you realize the customer was going to be using a TCO1, one USB port to one thermocouple? How many of those are really going to be needed in your system? Probably no more than 10. Maybe they can go crazy on it, but is that really the scenario? Did you ask? Did you even think to ask that? So that's where you don't have to be an expert at requirement gathering, but think about the things that are going to, think about scalable, modular, reusable, extensible, and then say, what are the things that I need to know? What can I take out of my system as variables and drop constants in to make the solving of that equation that much easier? Okay, so what? So we've been going for a while. Now I'm going to go into high speed because I don't really have demos for this. You must have wisdom to give it. You must have wisdom to share it. You must share wisdom to have it. It's not some kind of crazy ancient proverb. I just came up with that because it seemed to make sense. We are called to help the people around us. If we think we are wise, we are probably just knowledgeable, and we just haven't run into the problems yet. So we need to share with the people around us to bring them up. And then as we share with the people around us these ideas, we get feedback. And they actually help us realize this great idea that we had is actually kind of worthless. I did this once with I realized you could do a call parent method on LabVIEW classes. You could do it twice. You can call a parent at the beginning, and you can call a parent at the end. I'm like, that's kind of neat. And so I developed a whole architecture that utilized that, and 3, 4, 5 years later at this point, I look at it, I'm like, that was kind of pointless and wasteful, and actually causes me problems at this point. And had I actually shared some of this wisdom that I had at that time, chances are I would have gotten a little bit more feedback, and I would have changed how I did it up front to really do it. So a lot of this is a call to action. Is change good or bad? It was stressed to me that managers, engineers are very risk adverse. Why don't we change our programs? Because there's danger associated. Not only is there time associated with it just to do it, but there's a risk associated. The manager's job is to mitigate risk. But it's inevitable and scary. So what are the ways that we need to manage this risk? So you have to take on this risk, what happens? Well, that's that idea of starting out with those guiding principles up front. I'll tell you right now, I was part of the redesign of LabVIEW Core 3. And I was stressing to actually say, you know what, forget trying to teach the queued message handler and this and that and that as like some of the core principles. Let's just focus on people focusing on these principles. Because I can guarantee you, if somebody's thinking along these lines, they're going to eventually gravitate towards some of these architectures that already exist out there. Because they recognize I shouldn't make a stack sequence structure and hit run continuously. Because they'll ask, what happens when I need to add on to the program? What about if I need to... Don't worry, you guys didn't program that one. It was before I showed.
That's what you're supposed to do.
No, it is not what you're supposed to do. That is a bad design. So it's those guiding principles that will help us down there. Now, what about process improvement? We know change is coming. How can we make, all this stuff is like, how do we make change easier? Well, how do we stop change from even being necessary, maybe? If all that we're doing is playing whack-a-mole with bugs, either trying to get to the run arrow, or every time somebody walks over, you grab the hammer and you start whacking away, you're not improving the process. You're only perpetuating the problem even further. So there are certain things, find out what your problem is. How do you find out what your problem is? You have to start tracking it. We might not all be engineering managers, but one of the things that we can stress is to say, we need some way to track our bugs in our system. How many bugs do we have? How often is somebody walking over to my desk saying, your thing isn't working, fix it! And it's probably their fault, but it's our fault maybe because we didn't take their needs into consideration. Track that. How long did it take to fix it? Have somebody else look at that and say, that should have taken all of about 2 days to fix, or 2 minutes to fix, and you took 3 weeks to fix it. Why is that? You can't know how to fix something if you don't have any way of historically going back and knowing what's gone wrong. So often this is just tribal information, and it's one person. As long as that one person's at the company, we're good. What happens when he gets hit by a bus, or decides to go somewhere else and take that tribal information with him? We can't improve the process. So your manager's going to go, but there's money associated with this. I need to actually not have you on this because the time needed now is greater than the time that you have available. Let alone, the time needed now plus the time for change is even greater. So what do? Stop focusing on, well, we have to make a case to everybody that we talk to, if you care about this, to say it's not about how much money you're going to make by doing this. It's how much, or even how much you're not going to make at this point because you're pulling me off this project. It's how much are we going to lose a year down the line when a newbie developer walks in and decides to turn your queue-driven message handler into a LabVIEW style global, but you named your queue up front and it's in a distributed system, so now every one in your system, you've got 5 different things, everybody's using the same queue, and everybody's pushing on everybody else's queue because it's the same named queue up front. Yeah, it's something that I've seen. And there was a lot of time wasted trying to figure out that problem that could have been doing other things in the system. So that's the only answer that I really have in terms of where's the value in this risk. So this was very much the state of it. If you can measure it, you can improve it. So what are the first steps that we can do in terms of trying to get this message out? Set a higher bar for all that you do and you see. Set your principles. Write down 2 or 3 of them. You don't like my acronym? Hey, it's not even my acronym, technically. Have your own, I'm going to adhere to this basic standard of quality for what I develop and hold to it. I refuse to make LabVIEW style global. I started about 10 years ago stopping using them, and I forced myself to figure out more creative ways because I knew there was going to be problems down the road. And I've benefited from that as well. Lower your threshold for pain. So not only are you raising the bar, stop accepting stuff that you know not to be good enough. Once again, I've built, unfortunately, not the best reputation when I look at people's code, but I really, really stress how much I appreciate somebody when they actually had good, clean code. So the people that I keep nagging on, they're like, so-and-so. But the people that, I'll give the person a hug if I look at their block diagram and it's nice and clean and I can understand it. It's a beautiful thing. It makes it's like harps and angels. Every time the diagram opens and it's nice and clean. So that's what I try to push towards. Also, start tracking the cost of change. Once again, as I had mentioned before, fixing bug, time spent reviewing code, and also adding features. And sometimes, if you're your own dude in your own shop, you don't know what should be done better. But if you aren't, I would stress trying to share what you've done and ask somebody, did you think it should have taken this long? Also, we're getting right at the end here, work towards mentorship. This is a call to you as the people. You are the center of excellence in your organization, potentially. Raise those people up along you. Don't just push that column up higher and higher so that somebody can't reach you. Create your own tools. Don't be afraid, once again, templates or architectures. The things that you find painful, once again, lower that threshold, create tools to help you along the lines, and then once again, be that center of excellence. I would have given a laminated copy of this out so that you could bring it back with you. I don't have that. Hopefully the people at Developers Days may have a copy of that by the time that you get done. But I would, I would ask for you to take these concepts, these ideas, the acronym, and see how you can hold to it, maybe even for a month, in the stuff that you create. Ask yourself the questions, and then go from there. I believe that you will find value in what you create afterwards. Because I look at stuff that I made 2005. 2005 is when I created that the context health update part of it, that application, I can still go back and look at it and be proud of what I made back then. So even after a month, I bet you'll go back, which you did at the beginning of the month, and say, I don't have to reverse engineer everything I did. It's nice. So in the essence of time, I don't think we're out of time probably. No, if we're not out of time, gladly take questions. Like I said, all the examples should be whitewashed and available on the web. So if you like some of the ideas and tools that I used, you can grab them and go from there. Any questions about the topics or other ideas for examples that I should have talked about for the individual art student? Yes?
Why do you hate action engines on V2?
What about when you need a second?
Huh?
What about when you need a second?
Oh, yeah, of course. That is going to work.
That's scalability.
Well, I'm not saying as components, but like for sub-VIs, things like that.
Same thing.
Right.
What about when you need, well, one, I've been burned by them really, really hard and often because somebody else thought it wasn't a big deal. And they're like, my program's never going to get used in a multi-up situation, or they'll never get used in parallel with each other. And next thing you know, it gets run and people are asking, wait a minute, why am I getting results for this device over here and this device over there? Because the person that made that thing, and actually for those of you who don't know, you should all know this one, people who use the analysis libraries in LabVIEW, unfortunately, they have uninitialized shift registers in the guts of some of the analysis libraries. Now most of them do have a reinitialized primitive in the guts of it, but if you are using shared clones in your VIs, if you're using shared clones in your VIs and you use one of these as a sub-VI in yours, guess what happens? If you call that shared clone from 8 different points, that uninitialized shift register for however many smaller subset of clones it's created in the background, those values are getting tossed all over. So if you use those sub-VIs, your entire hierarchy has to be pre-allocated clones.
Yeah, I just find it really handy for things, just simple things like, for example, detect a rising edge. You make the code inline. You just drop that wherever you need. There's no.
What about when somebody uses that code in a shared clone? Sorry? What about when somebody uses that sub-VI in a shared clone?
I mean, the inline.
That's very interesting. Very few people recognize that.
Yeah, because I like if I'm doing an edge detect, something like that,
Sure.
go high to low, low to high.
Use a feedback node in line with the code.
Yeah, exactly. Well, yeah.
But no, I agree. There are places, but it ends up being very dodgy. And once again, if people go simple first because it works, you end up with irate people like me jumping up and down because I've got to redesign your architecture because you thought that was cool. So it's not that it doesn't work, and it can work, and you can be safe about it, but you got to be really, really careful, I'd say. Tyler?
So there's no answer, but would be a good discussion is how do you build into that architecture ways to prevent users from using it and scaling it inappropriately to keep them from running into those problems?
You can't. You can't. LabVIEW is a palette, and users are kids with a box of 185 Cradle crayons. And sometimes you've got the Mona Lisa in front of you, and they're like, sweet. And it'd be fantastic if you could work into the development environment ways to put bounds on stuff. And the best thing I could recommend is VI analyzer scripts. If you know that somebody's not supposed to have this sub-VI anywhere outside of this one stacked case structure, then make a thing that somebody can run to make sure that your thing isn't abused. Or somebody didn't go in and start dropping the global all over the place or crack open a VI. There's no, because we can't explicitly stop the compiler from compiling good LabVIEW VIs, we're kind of stuck in some scenarios. But that would be my recommendation for is like, hey, so somebody's got something and you know this is going to be a problem. Otherwise, sometimes if you put the bounds on it, you might make somebody who knows what they're supposed to be doing that much more hacked off. So there's the trade-off there. Good question, Mike.
Do you have concrete examples of how you encourage other people to follow this? I mean, especially for new users, it would be hard for them to understand the importance of it. And then there's some that just say, well, I need to get this done as fast as I can, or I don't have the time to do it.
This presentation is my strongest step forward in trying to make that the case. Because I'm trying to, one, hopefully the examples stress some of the realities of that. So that's the best thing that I can do is give really solid examples that people will go like, oh yeah, Oh, yeah. I have ran into that problem. I ran into that problem. I ran into that problem. So that's learning based on pain experienced already. And then giving examples of how to get over some of those things. There's not enough time for me to go into all the examples I could have. But as us, as people who are working in an organization, the idea of having templates, how do you address the problem with the uninitialized shift register? I created the extensible session framework, so I never have to worry about that problem again. So us as people who can create those templates and architectures, that's a good step forward. You can push it out to you. For people that are brand new, give them guiding principles. And every time you look at their code, that's another part of the presentation I didn't get to. The idea of code reviews is an easy word to say and a hard thing to implement. But if you have a kind of style guidelines is one of them, and another one, common set of questions that you always ask the people underneath you. What happens when I need another one of those? Show me how hard it is. Redline their code and say, until that's fixed, don't come back to me. It takes longer. And yes, sometimes you just got to get the job done. Totally understand. But that's that lowering the threshold for pain, raising the quality of standard. And then, effectively, it doesn't make a difference if it runs. Their code's broken until it meets your certain standard. It slows stuff down, but it's that cost of pain in the future. So, and us, we have to be advocates for that as well. Because people will look at us and say, what's acceptable? It drives me so crazy when systems engineering and I, supposed to be some of the lead users in the company, and they just look at a piece of code and be like, it's junk. What are the examples? You're going to show it to a customer, they're going to look at it, and they're going to say, that's the way I'm supposed to code. It's the way I coded it. It's the way, look at our examples before 2013. A lot of them hadn't been touched in a long time, followed poor coding practices and everything else. Once again, we recognized it, we changed it. Darren Nattinger took a lot of time and effort, along with a lot of other people, to refactor all of the examples for 2013, if not all of them, a darn heck of a lot of them, so that once again we can set a good standard going forward. Did that answer it?
Yeah.
Thank you.
I don't know if we really have time to cover this, but you touched on it a couple of times. What's a good way? So say I want to create reuse libraries, etc. What's a good way to get eyes on those? You've got Lava on the screen. You talked about like BI package manager, posting the community. I mean, I guess the idea is you want to present your ideas to people, get some feedback on it, and maybe even rev it a couple of times.
Yep.
But in your experience, was a good way to actually do that?
Persistence. It's the second time I've gotten this question the second time I presented. So I've gotten that both times. And all that I can say is that I have been personally I believe in the principles and the individual tools that I've made. And I tried to share it, and not everybody went, that's fantastic, and jumped on the bandwagon. And that was fine by me. So I had to be comfortable with what I made and the strength of the things that I made. And it wasn't perfect, but it was at least enough to go forward. And over time, it has built steam in certain things and more adoption. I'm not getting paid for it. It's nice to see your child out there really getting a lot of recognition, but at the heart of it, people are benefiting from it as well. And the only thing that's helped me get that in terms of making something and having it be valuable was just to be persistent. Because as a minimum, I'm the one who's using it. So I'm making my own life easier. And I know that if somebody else eventually took this on, their life is going to be easier as well. They just have to recognize that eventually. And when that happens, only then do you start to actually get some feedback in terms of, hey, this needs to get improved. And then eating your own dog food. Once again, be committed to how things happen, and then being, all those things in terms of maybe reverse compatibility and packaging it up so that when you go on to your next test system, installing it is that much easier too. So that's the, there's the aspect of persistence, eating your own dog food, and then, getting the word out through those different mechanisms. Have it ready. And also creating some training material. I hate writing training documents. I love writing training videos. It's kind of why I'm having this presentation recorded right now, because I don't want to have to write out all the context notes for all of these slides. And so there are tools available out there. Jing, J-I-N-G, is a free tool by the people who make Snagit and Camtasia for doing screen recordings, where you can record your voice as well. And so usually, if I go ahead and, actually I should be able to do, so I can go ahead and select a portion of the screen here, capture video, it's going to go 3, 2, 1, and then I'm going to go ahead and change my slides, and then I'm going to go ahead and stop. It's going to play it back for me. I'm going to hit that button, and now it's going to publish it out to the web. Come on. So it's going to upload in It's doing slow right now. But the basic idea, it's uploading to the web. When it's done, I'm going to get a link to it, and I'm going to share that. And so that basic idea of a tool that helps people learn it, instead of you being there, and instead of you creating a massive document of pictures, 1,000 words of videos, you want to have a lot more. So that'd be another way to, once again, people see it, they're curious, they want to use it, they've got to have something to go to. Try to give them at least a minimum of you walking through your code on the screen, and then go from there. But I think we're out of time. Thank you guys very much.